This conference will now be recorded.
All right. Any questions, guys, for me? Anyone? Any questions for me before I get started? Any questions out here? Again, I want this session to be more of, let's say, a kind of a recap. We'll try to see what are the interview questions that you need to, let's say, prepare out, and what are the kind of questions that you get out there. So I don't really want to cover a lot of new topics in this session today. Rather, I'll be addressing the topics that you have a question on, or what is, let's say, the area that you are facing a little bit of issue, so that we can look at that and kind of resolve that out there as such. Yes. Anyone, any questions still here that I can take? Correct. Hmm. Uh, you mean the pull request out there again? You will have that one instance of validation pipeline running. So you mean that at a point in time, let's say that there are 10 developers who are doing a pull request. So there's only one pipeline. Then how will it trigger multiple things out? That's where your self-hosted agent and parallelism comes into picture. You don't have to add multiple agents in the bill validation. You just have to tell that your bill validation is running out of a pool. The pool can have multiple agents. The pool, the agent pool. So in my case, if I go back into my, let's say, project out here, and if I go into the pipeline, there is validation pipeline. And as of now, validation pipeline is running, let's say, out of a hosted pool. That's the reason if there are 10 developers are committing this out, each and every developer has to wait for the pull request to get merged. So it will be a FIFO, FIFO, first in, first out. But if I am doing something like, let's say, my own agent pool, and let's say this pool has about 10 agents that is running, you also have parallelism enabled for on your Azure DevOps. So in that case, what's going to happen is that you are a first developer. You created a pull request. Validation is running, and validation is checking your code and etc. At the same time, the second developer has triggered this out. Even for the second developer, validation will get triggered, and this will run on the second agent. Okay, so this is going to run parallelly, provided you have parallelism, and provided you have multiple agents out here in your pool. Yes. Any questions? Any more questions here? So until now, in let's say Git, sorry, in let's say Azure DevOps, not Git, we started off with something like the basic process, that what is the agile methodology and all that stuff, and then we said what is Git repository, and I'll give a statement. I'll say Git is a centralized repository. Is that true? It's a distributed. Then my question for everyone is that then what is the difference, or what is the main difference do you feel is there between a distributed and a centralized repository? You have to connect to the server every time. Also, local, again, the main thing that you have to focus upon is this. In a distributed, you can maintain a local copy of the commit histories. In a centralized, that is not possible. In centralized, you'll have to connect to the server, and all the commit histories are maintained on the server only. So here it is distributed. Git is a distributed version control mechanism. And if you were to tell examples of distributed version control mechanism, it is Git, Azure repos. Azure repos is nothing but Git only. Bitbucket. There is something called Bitbucket out here. And if you want to give examples of centralized, there is something called TFVC, Team Foundation Version Control. And there is something called SVN, Subversion. These are the two examples of centralized version control out here. And inside Git, we were looking at multiple things like what are Azure repos. And in here, we were looking at what are branches, what is the importance of a branch. And that's where we came to something called branching and merging strategy. Very importantly, guys, see, when you are giving a DevOps, or when you are giving an interview for Azure DevOps, this is a gunshot question. They're definitely going to ask you Can you explain me something about the branching and merging strategies that was implemented in your project? Like, how did your workflow really go? So you'll have to talk about your main branch. You'll have to talk about your develop branch. You'll have to talk about the feature branches. And when you're talking about the feature branch, you'll also have to tell about the branch policies, which I'm any which way is going to come here and explain multiple branch policies that are there. About branch policies, you'll have to tell about your release branches. Also, you have to talk about the hot fix branches that are available, let's say, in your Git repository out there. So these are the things that we need to talk about. And we also need to tell what are the kind of, let's say, Git commands like git commit, git sync, git pull, git fetch, and there's something called git purge, git stash. All these things are the commands of Git that you have. So this is something that is important. And then we moved into build or continuous integration pipelines. So we are now into build and continuous integration pipelines, wherein based out of a template, we are telling how do you do a .NET restore, .NET build, .NET publish, and then also publish the build artifacts. And very, very, very importantly, when you are sitting in the interview, there will be scenario based questions, and the interviewer is going to ask you something like, uh, did you work on hosted agents or did you work on self hosted agents? What do you think is the difference between a hosted and a self hosted? And if you are using a self-hosted, why is your project going for self-hosted agent? Why not hosted agents out there? After that, if they want to go much more deeper, they'll just ask you telling, okay, fine. You know what? Can you tell me how did you configure a self-hosted agent? What kind of an authentication method did you use? Authentication method, what kind of an authentication we used out here while creating a self-hosted agent? How did we authenticate? Sorry, PAT. Yes, you're doing a PAT token out here. Then my question back to you is that you created a PAT token. What is the expiry of the PAT token? Okay, it's up to the user. Let's say you put an expiry of 30 days. My question as the interviewer is this. You are creating a self-hosted agent and the expiration of the PAT is 30 days out here. Let's say you created the self-hosted agent on, let's say, September 1st. Today is September 30th. PAT has expired. Will the self-hosted agent run? That would be a real-time scenario question out here, meaning this is something that you can only answer when you work out there something. But yes, this is a real-time question out here telling that, you know what, I gave a PAT while creating the agent out here. And after 30 days, PAT got expired because you have given a PAT called, let's say, 30 days out here. Now, my question back to, let's say, you is that then how do you, let's say, make sure that your agents are running? How do you make sure that your software development lifecycle is not blocked? Because if this PAT expires, what is going to happen? PAT is registration purpose. Good point. Yes. PAT is registration purpose only. PAT is only for the initial purpose. After you register it, the agent is going to generate its own token. There is something called JWT token. Again, when you are a developer, you'll be understanding what JWT and all that stuff is. JWT full form Java Web Token. So the agent, when it will run, it will create its own web token out here with Azure Devops, and it doesn't rely upon PAT anymore. PAT is only for initial registration. So even if the PAT expires, not a problem. Agent is going to, let's say, self renew itself using this particular token each and every time. So yes, good point. PAT, even it is expired, not a problem. Your agent will still be running out there as such. So very, very, very crucial questions out here. Again, let's go back into our Q&A section. So leave this section. Let's go into that particular wiki project out here. Where is that? In here, if you go into that particular Wikipedia page, here there are real-time questions and sorry, there are interview questions out here, and there are Azure DevOps that I've asked here. There is predominantly a good amount of questions that I asked here. Again, I said concept is repos and etc. Question number one is like, what is the difference between a centralized and a distributed version control mechanism? What category does Git come under? Then what do you know about branch policies? How do you configure a sonar? How do you, let's say, go and integrate it? What do you know about the branching and merging strategies? What is the strategy adopted in your project? What kind of a strategy that you do? Again, I went ahead and I said, please talk about the let's say the continuous flow, and also I've given the link for Azure DevOps Git branching strategy out here. Just scroll down, you'll be understanding what is continuous integration, how is it achieved, what is schedule builds, and I don't if can you schedule it at a regular basis. And then I ask things like, what do you mean by infrastructure as a code, and all these things. It's just going to come in our release section. But before that, what are the types of agents that are available? How do you configure a self-hosted agent? And then pipeline variables, variable groups, and all these things. So if you did work on Azure DevOps, the questions can be out of one of these areas out there, and scenario based. Telling, okay, if an pat is expired, what do you do? Or build is failing, what do you do? How do you troubleshoot? All these things out here as such. Yes. Any more questions here? Anyone? Any questions still here? Anyone? Any questions as such? Yes. See, test cases is something that your QAs are going to write. So they are going to write based upon what is the code that is written out here. Test cases, test cases basically gives you a scenario based test, telling that, for example, let's say you are designing a calculator. You written a code, .NET code, to design a calculator out here. So what the developer will do, or what the tester will do rather, is that they are going to write a test case. They're going to tell the test case, let's say, would be in, let's say, .NET or full framework or something like that. They're going to say that, okay, fine. After the code is built, I'll give a small work to the code telling that 1 plus 1 is equal to 2. Is it really printing that out? If yes, the test case is passed. Then 1 into 2, or 1 divided by 2. They are going to test multiple scenarios of your code to check whether the code is working or not, or whether the code is giving your expected output or not. This is the advantage, or this is the use of test case. But test case, on the other hand, is not going to identify issues like, do you have a syntax issue, or did you expose some kind of, let's say, security, let's say, hotspots, like, did you expose some kind of passwords inside your code, or did you expose some kind of, let's say, vulnerability inside your code? This is something that the test case is not going to validate, for which you need a static code analysis. That's the reason you put in Sonar along with a test case. That's exactly what I'm telling you. Testing in the build pipeline is to make sure, is to make sure that it is testing a scenario out here. Test cases look something like this. Let's go there also. They look something like this. It's called as a unit test.cs project file, and it's just going ahead. It's just trying to see, for example, do you see this? 1 plus 2 equals to 3. Is the code actually going and doing that? Is the code actually, let's say, trying to, let's say, do this particular thing? If it is true, test case is passed. If it is false, then it will fail. So using that test out there, you can call this particular CS project file, say, okay, fine, please run this test out. And this test will simply go ahead and, let's say, verify whether the code is able to perform this particular calculation. If it is yes, test case is passed. But is the test case validating your syntaxes? Is it validating whether you have passwords? No, it's not doing that. That's the purpose why you will get in something like Sonar or Fortify or White Source and all these things out here. Correct. Okay, what kind of error that you're getting? So very importantly, what is the error that you're getting when you're doing self-hosted out there? Same thing what Akshay is getting. That's what I was telling you, is that, see, there is a version of Java that Sonar really needs out there. So very importantly, if you're getting the error, the very first thing, copy that error, Google it out, understand what is exactly talking about, what is the version of Java dependency it is, let's say, missing out on. Take that Java, install it on your agent, then go ahead. Because the reason your hosted agent is working and the self-hosted is not working, let's see that. Let's go into Sonar. Let's come here. Let's see. Prepare analyzer, and it's looking for processing and all that stuff. Let's see, check out and all these things out. Let's see what are the softwares that are installed on this one. So it's saying prepare analyzer and all these things out. Operating system, image provider out here, included software. So if I see the software out here and search for control F Java, these are the things that are already installed. Java 8, Java 11, and Java, let's say, 64 out here. Please look for something called JRE. Java runtime environment. Java downloads runtime environments. Download these things that are there on your agent out here. For example, go to Windows, download Java 17 out here for, let's say, to begin with. Download the installer out here, install Java 17. Reason being, here they are using either Java 17 or 11 or 8 and it's working for them. The agent is, let's say, running. Also, after you install it, please go to your agent. Let's say in my case, I do not really have that, but let me go there. Go to your agent, say capabilities, see whether Java is getting reflected here. Like .NET framework is getting reflected. See whether that particular Java underscore home, there is a variable called Java underscore home out here. Please see whether that is getting reflected. If that is getting reflected, then your build should pass. Otherwise, sonar will fail. Yes. Any more questions that I can take? Anyone? Any more questions that I can take here? I think it's your time, guys. This is some time that I'm giving without taking a class. I want to address the questions. I want to address the areas that you're not really comfortable in. So, any questions that you have, please let me know so that I can address those and we can move forward as such. Okay. If there are no questions out there, then let's understand the different types of commits that are available out here. And again, when I say different types of commits out here or different types of git commits out here, there is something called there is something called merge. No fast forward. F4, no fast forward. FF. I'll just say FF out here. There is something called squash. There's something called rebase and fast forward. There's something called rebase and merge fast forward and all that stuff. So if you look at a branching policy, just scroll down. There's something called limit merge types. Just switch this on. Have all these things called basic merge, no fast forward, squash, rebase and fast forward, rebase and merge comment out here. Let's look at this. Firstly, let me go ahead and let's see, main branch I do have. Yes. So main branch has this particular file. I'll do one thing. I'll create a new repository, which is the best out here. Let's say test repo. The reason I'm creating a new repository is because I'm starting with a zero commit history so that you'll be able to understand what I'm doing out here. And here in the main branch, the history is what? Added the readme.md file. Let's create a new branch. Say dev1 out of the main. I'll say dev2 out of the main. I'll say dev3 out of the main asset or out of the dev2 asset. So anything is fine. So I have main dev1, dev2 and dev3. We'll test our commits. We'll take each and every commit type and we'll test it on each and every branch to understand how the history gets reflected. Now these commits are these commits are there in place to control what kind of a history you want, which kind of a history that you want to, let's say, get reflected out here. So let's do one thing. Let's come to the main and I'll create a feature branch right now. I'll say feature, then I'll say basic merge. We'll talk about a basic merge. We'll understand what happens out here. I'll say create. I'll come into my file. I'll give some commits out here. Okay. I'll say basic commit one. Commit. I'll say this is commit one. I'll do a couple of commits so that we'll be able to get a good amount of history. Basic commit two. I'll comment this out once again. I'll say commit two. And let me do one more commit. Let's say commit three. I'm committing this out. I'll say this is commit three or commit three out here. So I now have what? Three different commits that I did on my feature branch. I'll create a pull request into the main branch. So there are three commits where on my feature branch out here. So before I do a pull request, let's do that. Let's say commits on my main branch. How many commits that I have? One commit. Why do I have one commit? Because I created a repository, and when I created a repository, it just put a commit initially. How many commits will my dev branch have? Same thing, one. Dev 2, one. Dev 3, one out here. But the test branch is going to have what? Four commits. First commit was inherited from the main branch. So whatever the main branch has, this came from the main branch. After that, these three commits are directly done on what? The feature branch out here. Let's do one thing right now. Let's create a pull request. And now I'll say file is just one, but there are three commits on this file that I made. I'll say, okay, fine. I'll say this is a sample pull request. And the branch has no policy, nothing for testing. I removed, I mean, there is nothing that I've added. I'll say complete, and I won't delete the feature. And here I'll put this as merge no fast forward. Until now, we haven't even touched this. I'm saying merge no fast forward. I'll say complete merge out here. And I did not delete the branch. Okay, the branch is still there. The branch is still alive. I did not delete this out. Now it's telling merging the pull request. And after the merge, let's see. Let's come down to the commits. My feature branch has what? Four commits. My main branch has what? Five commits out here. What is it doing? This is the initial commit, right? This is the initial commit out here. When you look at commit 1, commit 2, and commit 3, where are they coming from? Feature branch, which means that each and every time you, let's say, do some changes in your feature branch, those commits are carried forward onto the target branch. And also, finally, there is one more commit telling that, okay, fine, this is coming from the pull request. So pull request is also calculated as one commit out here. So three commits are carried forward. One commit is coming from the PR. This was the initial commit that will stay on every branch no matter what. So what I am coming to tell is this one. If you go inside the branches, look at the branch policies. The easier way to read this is this. Basic merge. Preserve history exactly as it happened during the development. So the history of all your feature branches are also merged onto your main branch out here. But this might not really help you because see, you have, let's say, hundreds of developers. Each and every developer in a given hour is making around, let's say, 10 commits. 100 developers, 1000 commits. At the end of the day, your main branch, let's say it's a developer branch out here, every developer is merging the code on that. It will become very difficult for you to understand where the history is actually coming from. And also, it maintains a non-linear, let's say, kind of history out here, which tells you that, you know what, here is where the main got diverted. So it's telling I'm pulling a new branch out here. All these commits are done onto that particular branch, and then I'm merging it back. If it was a direct commit onto the main branch, let's put a direct commit on the main branch out here. This is a main commit. Commit. I'll say main commit. Pull request is not permitted to this branch because I unintentionally put a branch policy there. I'll say leave. Let's come on to branch policies. Let's take this policy out. So I unintentionally went ahead and, let's say, put a branch policy. Just remove this out. Refresh the screen. Main branches doesn't have a policy right now. So let's go into the main branch. Let's say edit. I'll say this is main commit. Let's say comment this out. Okay, main commit. Now put this commit history. Now let's look at this one. Let's say commits main. Do you see how now the commit is being tracked? Now it's telling this is directly on the branch. If it's not, then it will pull something parallel line out here telling, okay, fine, the development has happened. All these things were on the feature branch. Finally, you merge the PR into the main branch, and finally, there is one commit onto the main branch out here. Again, this is the tree or this is the branching structure. So you pulled out a branch, did all these things out. If this is confusing, just click on the off button here, which will give you a linear history telling what exactly that you did and all that stuff. Again, a basic merge might not help you in all the cases, especially when your team size is super big. If your team size is big, right, you don't want to understand what are the commits that are made on a feature branch. I don't really want to track that out because it will become very difficult for me to keep a track of it to keep a track of it, let's say, in a given period of time. Because in this hour you come, you see, okay, fine, the commits are good. The next hour you come, 100 developers have done some commits out there. There will be literally 10,000 commits out here. You'll go literally mad out there telling which commit came where, how did it really come at how did it really come out there. It become really difficult for you to, let's say, understand. But if you want to carry forward the development history, then you are going to use a basic. If you want to carry the history forward, let's do one thing. Let's understand squash. What squash really is let's see this. Now I have a branch called test branch, Kiran Basic out here. Let me take this branch, create a new pull request. I'll say merge Kiran Basic into dev1. This time when I merge it, I will do a squash merge. I'll say this is a squash merge. Same file, 3 commits onto, let's say, that particular branch. I'll say create. I'll say complete, and while completing, I'll say it's not merge fast forward. It's not merge no fast forward. It says squash. I'll say complete this out. So I'm doing a squash merge out here, and now once I do a squash merge, let's look at this particular thing back out here. Let's say commits. Feature has what? Commit one, commit two, and commit three. Main undergone or main basically took a basic. Same, let's say, thing that I did on dev one. It is not considered about what are the commits that are done on your feature branches out here. Development history is not carried forward. It is a clean commit history. It's a linear, it's a clean commit history out here, which means it's just telling, okay, fine, you know what? You did a commit on this branch because when you created this commit is going to, let's say, get carried forward. This is there. After that, using a PR, I did a commit on this one. This is a squash merge. And if you are interested on this particular, let's say, development history, click on the PR, understand which branch it is. Then you can say, okay, fine, this is the branch. Look at the branch history. This is how, if you want to, let's say, go back and look at the history of development, you can go into that particular feature and then look at that history out there. This is useful. Squash is useful, especially if your team size is super big.